we replace one or more hydrogen in ammonia by alkyl group, so the compound which is formed is known as amines. Consider we have ammonia NH3. This is NH3. And here we replace one hydrogen by alkyl group, so the compound which is formed is RNH2. If we replace two hydrogen by two alkyl group, so we will get RNH bonded with R. If we replace the third hydrogen, so we will get R bonded with N, bonded with R, and bonded with R. So here in this case, we have one alkyl group. In this case, we have two, while in this case, we have three. So this is primary amine, this is secondary amines, and this is tertiary amines. In this case, we replace one hydrogen, here we replace two, and here we replace three hydrogen. But in this video, we will basically talk about the structure of amines and the bond angle in which type of hybridization take place in amines. Consider the tertiary amine. So we have nitrogen. It is bonded with three alkyl group. This is we have R1, this is R2, and this is we have R3. And you know, here we have also one lone pair of electron. This is lone pair of electron. If we look at the electronic configuration of nitrogen, so we know that it has 7 atomic number. So in first we have 2 electron and second we have 5. So here 3 electron is covered by bonding with carbon. Here it is basically CH3. CH3 or any other alkyl group or aryl group, and the remaining 2 electron is here we have unpaired, which is known as lone pair of electron. So as we know that this amine has been derived from ammonia. So ammonia molecule has a trigonal parametral geometry with a bond angle of 107.5 degree. If we talk about ammonia, in that case here we have only hydrogen. So where the bond angle between hydrogen, nitrogen and hydrogen is 107.5 degree. While in this case, as we know that amines are the derivatives of ammonia, so it has also a trigonal structure. But the bond angle between R, N and R, this is R, N and R, R, N and R, R, N and R. It's slightly greater than that of ammonia, than that of 107.5 due to greater atomic number of alkyl group. So it has the same trigonal parameter structure just like that of ammonia. Now we will talk about hybridization rate, which type of hybridization takes place here. So we will take the general example of methyl amine. Methyl amine means CH3 bonded with NH2. This is we have methyl amine. Now we will open its structure. So we have carbon mainly bonded with nitrogen. Carbon has 3 hydrogen, 1, 2 and 3. And here in this case nitrogen has 2 hydrogen, which is this hydrogen and hydrogen. And you know it has also one lone pair of electron. This bond is basically sigma bond because it is formed linearly, and we know that when bond is linearly formed, that is known as sigma bond. While if bond is formed parallel, that is known as pi bond, and that is formed like in this way. Every double and triple bond will always pi bond, and that is formed by sidewise overlapping. Consider this as we have p orbital and this p orbital. So this type of bonding is known as pi bond. So here this is we have pi bond, And each carbon here, nitrogen and carbon both follow, and they are both are sp3 hybridized. And we know that as we talked in structure of alkane, that if carbon is bonded with 4 atom through single bond, so that is known as here in that case we will follow sp3 hybridization. So here each carbon is sp3 hybridized, and it is attached with hydrogen, which is basically S. It is so clear. But if we talk about nitrogen, so it is a little bit complex. But first we will just follow carbon, that how carbon is sp3 hybridized. So we know that carbon has atomic number 6. So if we look at electronic configuration, we will get it is 1s2, 2s2 and 2p2. So here we have in S we have 2 electrons, and P we have also 2 electrons. So here is give electron to our third shell, so we will get, sorry, it is also in same spin. So now we have 4 atomic or hybrid orbital, which is belong to 1s and 3p. So this is known as sp3 hybridization. But in case of nitrogen, we will follow through simple rule, which is like this. If we have X plus E is equal to 4, so that is sp3 hybridization. If this X plus E is equal to 3, so that is known as sp2. If X plus E is equal to 2, so that is sp hybridization. Now what is X and now what is E? So here X is number of bond and E is lone pair of electron. Here in carbon make 4 bond and there is 0 lone pair. So it becomes 4. So each carbon is sp3 hybridized. But in case of nitrogen, it is bonded with 3 atoms. One is hydrogen, and one is carbon. So here we have X is equal to 3 plus, and E mean lone pair of electron, and nitrogen has 1 lone pair of electron, so 3 plus 1 is equal to 4. So it is also sp3 hybridized. So nitrogen is also here sp3 hybridized. Hydrogen, we know that it has only one shell, which is S. So it is sp3 bonded with S of hydrogen. And here all the bonds are sigma bond because they are linearly overlapped with each other. So I hope the structure of amines is clear now. Thanks for watching.